Data-driven science is the future. There's always been data in the background, but now the data is really driving the systems, and that's a big change. We're at the beginning of just a revolution in how we understand the way the weather and climate system works. And that revolution is being driven by how we're able to interpret data from the past. Historically, these models were based on these complicated equations that we put on computers like a cookbook recipe, driven by mathematical formulas. Now these models are going to evolve, and we're just beginning that evolution. So instead of the basic equations determining how that recipe works, data is going to determine how that recipe works. It's a totally different way of thinking about physical modeling of our environmental systems. Our niche is solving pragmatic problems, day-to-day problems, making sure that decisions are based on the best available evidence. And what we're trying to do is make sure that the data science that we're doing is applied to pragmatic problems. Other places, they may focus on the theory and how do you make better data science techniques, whereas we're really thinking about how do we apply the best available today data science to solve the problems that need to be solved today. Look at it from a forecast perspective. What can I say about environmental hazards 6 months from today, 2 years from today, 10 years from today, 50 years today? Can I make a better estimate of what hazards people are going to face? Can they plan so that those hazards don't interfere with their well-being? So the students, not only are you getting hands-on real experience, but you're getting hands-on real experience with cutting-edge technology to test that theory that you get in the classroom. This is the beginning. The next 20, 30 years is just going to be just a tremendous transformation in how the research I'm involved in, how that's going to evolve. The tools that we use to do our research is going to evolve.